The question is of C6H5CH2Cl and C6H5CH6H5, which is more easily hydrolyzed by aqueous KOH. So hydrolysis by KOH will take place by the formation of carbocation in its RDS or rate determining step. So the compound having stable carbocation will hydrolyze faster. So this is the first carbocation that will form for the first compound, this compound. And for this compound, this carbocation will be formed. Okay, so you just have to compare the stability of the carbocation that will be formed, because this is the RDS or the rate determining step. Okay, the one which has the most stable carbocation in the RDS will get easily hydrolyzed. So it is clear that this is more stable. Why this is more stable? Because as you can see, the electron density, that it is double bond here, and it is a benzene ring here, and it is also a benzene ring here. So there is a lot of conjugation present. Okay, so since there is a lot of more conjugation present, there will be more electron density on this positive charge, so it will be more stable. As you can see, there is only one benzyl group. It will get less electron, and thus the electron density on this carbon atom will be less than this carbon cation. Hence, this carbocation will be much stable because of the more electron density on the carbocation. Hence, this compound will get easily hydrolyzed as compared to this.